Hello, everybody. My name is Patrick Chase. I am the co-founder of Empire Space. Proud to welcome you to another Spotlight event, part of our Space Week New York 2025 series. It's a mix of in-person and virtual events highlighting all of the great work being done across New York in the space sector, in the space economy. One of the things we like to do is highlight innovative companies that are based here in New York who are doing interesting things in the space economy. So today we are joined by Hunain from Melagen Labs. We've had an opportunity to connect with him a number of times. He's doing some really interesting work that we're very excited to share with the audience today. So yeah, welcome. Thank you for joining us.
Yeah, thank you so much, Patrick, and super pumped to be here and excited to share about the story of Melagen Labs. And I'm co-founder and CEO at Melagen Labs, where we're building bioengineered hydrogen-infused radiation shielding material for space assets, which can be 3D printed and can also be coated on electronics. And just a little bit about me, I moved to America about 5 years ago from Pakistan. And since then, I've been just super obsessed with space. I've watched astronauts launching to space and, of course, saw tons of satellite launches and a few rovers, of course. So that was something which made me very curious about space and why we're going up there, and made it an ultimate goal in my life to actually become an astronaut. And while I was looking into how astronauts become astronauts, I came across the challenges they also have to face in space. And one of the biggest risks they face is space radiation. And astronauts actually get 10,000 times more radiation exposure compared to terrestrial levels. And that can really cause 13 different types of cancer within just 3 to 4 months in deep space. And if you look at the current way to shield our assets in space, it's aluminum, and we've been using it for decades. It's expensive, heavy, degrades in space because of the extra radiation it also causes. So it's just not sustainable anymore. And when you look at now, about 38% of satellites are affected by radiation, and over $2 billion is lost every year to satellite operators. And we're going to launch thousands of satellites in the next few years and double what we've launched in next few years. So those are a few key things that actually got me into space radiation research and led me to work alongside NASA as well as a project manager on their L-Space program. And we were developing concepts of Mars rover, and radiation for that was also a top challenge because we were putting on high compute onboard computers, which were high risk when it comes to space radiation and being in space. So that actually then led me to do some research in material science, and I came across some unique materials that had shown high attenuation, primarily biological compounds. So I was like, that would be a cool project to do, and I started pitching a few investors about this and was able to actually get some checks to actually build a proof of concept. So I sourced the materials and actually got a radiation source to test and was able to get some real data. And that's when Melagen Labs was born in a garage. And of course, the radiation source was safe, and also the dose was safe enough to be around. But all of that happened in a year. And there was a lot of cold outreaching to scientists and CEOs, talking to satellite operators, learning about the pain points and failures, etc. But really glad where we are now and happy to share a bit more.
So thank you for that intro. That's, I think, a really interesting kind of overview. And now I think there's really, I guess, 2 tracks that I'm really curious about. One is kind of the more human side of things, building a lab, starting up in a garage. Like, how did you build a team? Tell us about your team now and what it's like to, grind that out and kind of make that work. And then also just the material side of thing. I know you just kind of dropped, bioinfused something, and just kind of bore into that. So whichever one of those you want to take first.
Yeah, I was actually in college when I was doing all that research, working on the rovers and all that stuff. And at that time, I was doing research with very cool scientists and had already developed relationship with them. So that was space radiation research. And over time, when I was actually building things, I realized that I'm not going to be able to do it alone, because um, I also felt that entrepreneurship is going to be the way to bring this to actual, commercialization phase and put it in front of users. Uh, in That's when I started looking into, okay, who's going to be the best team members to start with, like the core team members, who will have the discipline to be part of startups, who will have the discipline to actually get things done and then be fast enough to move forward as well. So I decided that I'm going to work alongside some of the scientists that I had already built relationships with. So my CTO and co-founder, his name's Dr. James Seacrest, U.S. Navy veteran, brings in over 25 years of experience in biotechnology and have done radiation shielding for some programs at Siemens and also some other key projects related to space. And he's been in the industry for about 10 years, specifically for space, and have started space businesses before as well. So really great to have him on the team, and very experienced, knows what needs to be done and keeps the technical team aligned and moving forward. And I was also able to loop in my mentor, actually. I was part of an accelerator. It was called TKS, the Knowledge Society. It's only for teenagers, 13 until 17. And he was my coach then, director of programs in New York City. And I realized that we work close. We can work together. And I had learned a lot of things, and he helped me improve very fast. The program was just a couple of months, and I was able to launch a company because of that program as well. So he had experience in business development with Johnson and Johnson, and seemed like a good fit. So I was like, yeah, would love to work together. And then my CTO brought on a chemist who also had PhD in radiation physics and also organic chemistry. So it was just some weird mix, but it worked out for us. And that's how we've been developing the team. So today we're a team of 7: radiation effects engineer, chemist, CTO, business development, and a few other key team members as well. So total of 7.
Nice. That's amazing. It's always inspiring to hear that kind of, idea pops up, and then just kind of hearing the process of just how someone, just grinds it out and builds like an actual company. And now I want to, learn a little bit more about what it is you guys are actually doing. And so this novel material that you've discovered, and just kind of, so I know we use aluminum and it has all these downsides. Why do we still use aluminum? And then what is this alternative that you're developing?
Yeah, definitely. So when you look at the past, right, we've only launched about 12,000 satellites since the start of space, approximately. And most of those satellites didn't had high compute systems. So an average high schooler also knows that their TI-84 calculator is much more powerful than some of the chips that we've actually launched to space. So the transistor size matter a lot, and they are just not at risk of radiation. But when you look at now, we're building high compute systems, we're building data centers in space, we're putting up AI chips, and they're just at high risk of radiation. And radiation causes bit flips in those systems. So in their memory, it's 0 to 1, 1 to 0, and you have downtime then, and you're not able to access the satellite. And if it's severe, it could also kill the satellite. So that's mostly latch ups. And so those are a few things. And also aluminum doesn't outgas. And then also it provides structural integrity to the system as well. And that's why we've been using aluminum as a go-to for radiation shielding. But like I mentioned, when it's in space, it degrades in space. So it causes more radiation, which is called secondary, and produces extra particles inside the material, which can still pass through and so cause those single upset events and memory glitches. So it's still not sustainable now. And again, it's heavy. So what we ended up building was a lighter material. It's 3 times lighter. So it gives you the flexibility of adding more fuel. So you're extending your mission lifespans. You have the ability to put on more payload, your scientific payloads or commercial payloads, hosted payloads. That is the flexibility that comes with this material. And still, it's 2 to 3 times more effective, depending on the orbit and the environment it's going into. In the basic tech behind it is really the first principles that we have. So when you look at radiation particles, they're traveling nearly at the same speed as light. And so we have materials that have high stopping power. So usually high Z materials that really slows them down. And then we have a hydrogen layer as a polymer, polyethylene, which really absorbs the secondary radiation as well. And then the biomaterial, which also just helps with no degradation and keeps the structure as it was supposed to be. And we also have another layer of low Z, which just really stops and then absorbs the leftover. So there's very minimal radiation that goes through and affects the electronics. And we've done a mission where we actually compared our shielding with aluminum. So in a 15-year geo mission, aluminum had about 4,000 glitches. So 4,000 times those bit flips. And our shielding only had less than 80. So because of that structure that we had over the course of 15 years. So that's the value that we're adding. Did that answer all your question, or did I miss anything?
That was incredibly comprehensive. And there's so many follow-ups that stem from that. So I guess the first one, the obvious one, and you could kind of mention this at the top, is just kind of the range of applications. So I guess just kind of walk us through the number of different markets or customers that this could apply to.
Yeah, great question. So space radiation is definitely something that we're starting with, right? The space market, beachhead, and then protecting satellites, rovers, lunar habitats, defense contracts, and things like that. But then, of course, there is still terrestrial applications. So it's a dual use technology, which can be used in medical and then also nuclear reactors. The workers there have to use lead shielding, which is toxic and very heavy, and they have to wear super heavy gowns. So we have the ability to shield on a fiber level, meaning we can make flexible clothes or gowns that the actual workers can wear, and it still will provide effective shielding, and they'll be under the safe limits. And we've talked with radiologists, neurosurgeons, and also nuclear reactor workers, and have gotten validation and feedback on that as well.
Okay, that's really cool, and it's always fantastic. I mean, we're all here for the space, and space exploration, and the applications of this to space exploration are, of course, gigantic, both human and, as you described, technological systems. That's something that most people probably don't think. Even someone in the space sector like myself, yeah, most stuff from years ago, or the more basic stuff that's ever gone up, there was only so much that was needed. But now, with much more advanced AI systems, data centers, the more complicated modules that you're going to need to actually send large numbers of people any distance out into space for any amount of time are going to be much more complicated and much more vulnerable to those radiation impacts. And then another point is just how much this conversation ties into other conversations we've had during Space Week. The earlier spotlight we had was on space sustainability. So you're talking about reducing degradation over time. That keeps things functioning and safe longer, reduces space junk because things don't fail as frequently and everything like that. It ties into some of the panel discussions we had yesterday about space medicine. Most of that work is grounded in radiation research. So that's just a sidebar about how much I love about this week, and how much all these different panels that you wouldn't think necessarily like, a sustainability conversation of material science, but then you really get into it, and there's so much crossover and applicability between different components of the space sector. So that's really cool. And then I guess it just kind of ties into my next question, which would be, working here in New York, do you have partners and affiliations? What's it like, bringing this type of business, working in this kind of field, up the maturity ladder here in New York?
Yeah, great question. I think I can go on about this a lot. Like I can talk about this for hours, just how great New York is. But of course, as a deep tech community, deep tech company or space company, we have the basic infrastructure to actually build our systems out. And those resources are given by organizations like New Lab. It is now becoming a deep tech hub for New York City ecosystem, where we have prototyping labs from 3D printing, metal workshops, electronics lab, bio lab. So we could actually build stuff there within a matter of a month. And then the question becomes, how do you test it? Because when it comes to space, you have to test things over and over and over and again. So that means actual radiation testing. That means thermal testing, environmental cycling, and then also vibration. So those are a few things that I definitely miss. But I believe New York Consortium is working on that. So where we can go, and then if we have a TRL1 technology, we can actually take it up to TRL9, and then actually get support on launching it to space as well. So those were a few key things that I learned when I was talking to them, and I'm super excited about that. They also have the capabilities to test systems, so that's super exciting. But in terms of like the community, the capital, investors, and then also being able to find talent, it's all here. And I think it could be a great way to start. But when it comes to manufacturing and scaling, we definitely need a few more incentives. So that's where the government also has to kick in, and then also provide some resources, right? So those are a few things that I would love to see more. But I think as a founder in New York, it's been great. We have a lot of networking events as well. So we get to meet with potential customers, great partners as well. And there's been many companies that have launched from space and then scaled in other state or city. But if we look at now, we even have a space suits company in Brooklyn Navy Yard as well. So we also have a satellite company here in Brooklyn Navy Yard, and a few other. So definitely the ecosystem is there, and it's a great foundational start, but there needs to be a lot more resources when it comes to manufacturing and scaling.
No, and I think that message just kind of perfectly encapsulates kind of our perspective as well. It's great to hear that there is a community to kind of put down those roots in those partners. Great shout out to New Lab. I put a link to New Lab in the chat. A lot of companies in recent years have set up shop there, and then you're right. It's not all sunshine and rainbows, and that's one of the things that we do focus on here at Empire Space, is that there are some of those challenges that companies face when it comes to testing, scaling, those kind of applications. That's why we're proud to be a partner of the New York Consortium for Space Technology, and that's why it is a key focus area moving forward. Quick shout out to our needs assessment project, which is digging into the details of some of these questions, and we'll be digging more into that in the summer. So it's a really fascinating application with a lot of different markets, a really cool technology, a great story. So where is it going? When you see Melagen in a couple of years in terms of growing the team, actual demonstration, getting it on, missions to space. What does that timeline look like to you?
Yeah, definitely. So our aim as leaders of radiation shielding is really to protect majority of the satellite launches into higher orbits. So think MEO, GEO, and then cislunar as well. And that also includes rovers, data centers, space stations, lunar habitats, and deep space missions. In our shielding will be integrated into astronaut suits and vehicles, so that'll ultimately reduce mission failures and radically extend the operational lifespans of those missions as well. So our material, the aim is really to make this a standard for radiation shielding for space missions, because it's lighter, stronger, and effective than anything else right now on the market. And that's not, like I mentioned before, we're not stopping there. We will expand into other markets like aviation, defense, and healthcare, nuclear, replacing the outdated shielding that we've been using for decades, which is bulky, and it's still ineffective at the end of the day. And of course, that's not going to happen by accident. We will have to make it happen. And one way is to build an elite team who's literally obsessed with solving this problem and pushing the edge of what's scientifically and commercially possible. And to be able to get to that, we're actually launching our material on a Transporter 15. So that's something coming up, and we've been working really hard on. And it's just like piggyback on someone's payload and hosted payload. So we're pretty excited about that, and it's going to be placed in an SSO orbit, sun synchronous. So we will get exposure of radiation, and we'll get some cool data out of it.
Oh, that's really cool. What's the timeline on that mission?
So Transporter 15 through SpaceX is Q2 of this, Q4 is this year.
Okay, so
Yes.
cool. We'll definitely keep an eye out for that, and we'll definitely all the fingers crossed for that. So when you meet with potential companies, satellite manufacturers, sometimes the industry can be very set in its ways. I mean, you've described a number of times how we've been using aluminum forever. So maybe, the industry is like, it's the devil we know. What kind of trends or feedback do you get? Are industry partners looking for something new, or is there a mentality of, well, it's worked so far? Or is there an acknowledgement that this next generation of much more complex spacecraft is going to require something new?
Yeah, definitely. So we've talked about, data centers, and then also lunar habitats. We've talked about high compute systems. So we have interest from all three different sources. So, and another trend that I've seen, or we're continuing to see, really is that we're moving from exploration phase to actual infrastructure, right? So whenever there's a space company, they just want to go to space and just get some data and have some space heritage. So their systems don't have to last for years. So that's just like testing. Even a month of testing could get that. But now we're transitioning to actual infrastructure. So when it comes to data centers, they cannot fail. When it's scout missions from Artemis, they cannot fail. So when it's DARPA coming out with the call of, okay, we have this mission that we are trying to look for water on the moon, and we need a reliable system. So that can't fail. So we're going through that transition where we're working with companies to support on their actual missions in next few years. So the design of those missions starts now. So it's really that, okay, they're working on, proving their tech out with what they have on the market with aluminum, but then ultimately with longer missions, they need high reliability, not just for themselves, but also for their customers. So that's when we're working with them. Is that what you're asking?
Yeah, no, that's good. It's good to hear that industry is, receptive to that and acknowledging the need. It wasn't necessarily the takeaway from the space sustainability and the space debris conversation. So good to hear that partners are out there and interested. So
we're actually overwhelmed with the amount of interest we have. So we're working with just select few companies in getting heritage on our material as well, and then that's how we strategically plan on scaling and expanding our manufacturing as well.
Excellent. Well, that's good news. We're great to hear that. I did put the links to Melagen Labs LinkedIn and the website again in the chat. We are about to hit Q&A. So if folks have questions, feel free to put them in the chat or just raise your hand. So I guess just final thoughts from our conversation over to you, points that you had wanted to make that we hadn't touched on, where folks can find you for updates, how to get involved, partnerships, things like that.
Yeah, definitely. I can put my email in the chat, and please do reach out if there's any questions or any way we can elaborate on anything. And of course, I can also put my LinkedIn in the chat. That is just another way to reach out. Awesome. There you go. Yeah.
Thank you for that. So glad that folks will be able to reach out, and then definitely we will keep an eye out for that information about the launch coming up later this year. That's going to be really cool. So now we'll turn it over to folks from the audience. If there are any questions based on the conversation we've been having with Mohammed from Melagen Labs. Sure, go ahead, Rama.
Yeah, awesome. Of course, I know Mohammed, and I was just with him yesterday, but I think I didn't quite grasp the scope of what he's been working on until literally right now. So well done, first of all. How can we be helpful, right?
Yeah.
This to me, I think. I mean, I'm not a New Yorker, but I'm here right now, and my lead investor is here, and there's just so much going on. How can we be helpful for you and your journey?
Yeah, thank you so much, Rama, and of course your time yesterday as well, and excited to catch up later today as well. But if you guys are connected to any satellite manufacturer, would love to talk to them, and if there's any way there could be an intro opportunity, would love that. And we're also going to be fundraising pretty soon, so if you guys are connected with deep tech investors, so Rama, like you mentioned, your lead investor, would love to talk to them as well. And we're also hiring and looking for really great mechanical and then also electrical engineers. So if you guys are connected or know somebody who would be a good fit and who would love to learn more about Melagen Labs, I would love to talk to them as well.
Cool, think makes sense.
Thank you, Rama.
Awesome. Yeah, thank you. I guess that back and forth, I guess, provoked another question for me. Is there a space materials science kind of community? Like, is there a network or like an academic framework that you are able to like partner with on like research, or is it kind of just you guys have your own unique path?
Yeah, we're actually working on a few more partnerships, so I can't talk a lot more about that. But some of the best universities are actually working on some cool material science projects that could also help with radiation shielding. But then also they want to collaborate together. So we're working on that, and there is a huge community for it. There are people out there who care about it and who are trying to change the status quo there. So I'll definitely share those communities at the right time when it's like tangible.
When it's applicable. We understand the need for that, because that's also a question we always ask ourselves here is the academic component of New York space ecosystem generating the talent that feeds into these companies who are looking to grow and scale. After the number of times the space radiation has come up this week, I think we probably need to encourage some more programs in that.
I'll tell you one thing, it's really hard to find a radiation effects engineer. We were able to source or like find somebody from Florida, and she's super cool actually. And the mentality that she has is also critical to startup environment, right? She's been seeing the trend of aluminum being used in the industry for quite some time. But then she noticed that there's not anyone working on this. So she wanted to just do her own research, work something out herself and do more research and get PhD in radiation physics. So we're working with her and onboarding her on the team. But one thing I'll tell you is it was really hard to find someone like that. And we definitely need, at least for Melagen Labs, more radiation effects engineers. And electrical engineers who have background in radiation physics and understand the risks of radiation to electronics in space.
So maybe it's a lot of that kind of multidisciplinary. That's definitely an interesting thought. We'll follow up with you. Our next conversation, we're gonna want to learn more about what fleshing out that pipeline would actually look like. Because, and again, to kind of just touch on the similarities, I would have to imagine that there are probably somewhat compatible programs in medical schools for people who are going to be going into cancer research and then work on, radiation. So it's finding those sometimes maybe not inherently obvious connections that could lead to a fruitful conversation down the line, because that's how we grow space here in New York. Because you guys are a perfect example of a company, brilliant idea that could be absolutely transformative for the space ecosystem, put a team together, ground it out, made it work. Now it's about New York fostering an environment where you can grow. And that you're still doing this work, but just at a bigger scale with more impact in 5 years. And so much of that is the talent. Are you able to access, the engineers and the other technicians that you're able to, in addition to those testing facilities?
No, I think we would love support on that, and shout out to Empire Space. And I know you guys have helped some other companies, so definitely need support on that end. And yeah, another thank you for putting this Space Week together. And I believe people are enjoying it, and definitely going to catch up with you guys later at another event. But in terms of the medical talent, when we look into radiation physics, it's very confusing. The radiation that you get in your X-ray machines, it's going to be completely different when it's in space. So it's completely different specialization, but that talent is going to be very useful, and will definitely help a ton when we're looking into other industries like medical and then nuclear, right? So if you know anyone, I'd love to talk to them, man.
Yeah, I think you might have some interesting conversations with some of the folks from the space medicine panel, and it's great. I'm glad you've been enjoying Space Week. We had a great reception Monday night. We got another one tonight, and then again on Friday. Questions again from the audience. Again, feel free to put them in the chat or ping a hand. Oh, we lost one of the note takers.
Awesome. We covered everything.
No, we did. That was it. Really is a great story. I didn't know, Quadri, you had dipped in and out. I didn't know if you were hoping to ping a question here before the end.
Sorry about that.
No worries.
Technology still eludes me apparently. One of the questions I had was, when it comes to radiation, I'm sure we have different levels of radiation when it comes to the protection of equipment and assets versus the protection of humans in space. Is Melagen Labs looking into the level of protection that I guess different missions will have, and providing different levels of products to whoever needs it based on that mission?
Yeah, great question, man. So I can take 2 minutes and go over it. The way we work with clients is really that we get to know their radiation environment. We learn about what orbit they're going to be in. We learn about what components they're using. Are they radiation hardened? If they are, then of course there's very less work to do. But then if they're not, then we have to do a lot of modeling about, okay, they're going to be placed in that certain orbit. And then we have to make sure that they're going to last for this amount of years. So that is going to be defined by your end. So if you're a client or a customer, you will have to come on board and tell us that, okay, this is my satellite, this is how long I want it to last, this is my mission timeline, these are the components. So we'll take care of everything then and develop a radiation shielding model specifically for that. And it's not going to take us a month or two. We can get it done within 2 weeks from radiation analysis, the first touch point, to actually delivering the shielding. But since we're starting off in our setting systems and manufacturing, it will take us about a month just to start things out. But ultimately, it's only going to take us 2 weeks when we start to automate a lot of things and have just like one assembly where we're just pumping out those shielding prototypes or product. Did that answer your question?
Yeah, I sort of have a follow-up question because you had mentioned a specific orbit, um, and this might be a question more for radiation scientists. When it comes to solar radiation, does orbit, low Earth orbit, high versus geosynchronous, and then I guess lunar transition, does that affect the level of radiation, or are you more looking at I guess timeline of the mission itself?
Yeah, so the first thing matters a lot, the altitude, right? The orbit. So if it's low Earth orbit, we don't have a lot of radiation there. There is radiation particles, primarily protons, that cause a single upset events or glitches in space, but we still have protection from Earth's magnetosphere, which is sort of deflecting the radiation particles that come from suns, solar flares, right? So we still have some protection in low Earth orbit. But when we go from LEO, low Earth orbit, to medium Earth orbit, and then higher GEO, and then cislunars, L1 or L2, we have to, or the manures will be exposed to Van Allen belts. So that's where a lot of the trapped radiation is. And that's what causes higher radiation levels in higher orbits. When it comes to those orbits, about 20% of the total weight is dedicated towards radiation shielding. So again, it's mostly aluminum, and then also it is one of the top priorities. Depending on the mission timeline, it could be about 15% as well. But on a safe side, it's about 15 to 20%. And of course, that also comes with the budget and radiation hardened equipment, or like the components that are usually about 100 times more expensive than the commercial off-the-shelf component. So a radiation hardened component could be $1 million, whereas a radiation non-rad hardened onboard computer or component could be less than 100,000, 200,000 as well. But if you use our shielding, we can achieve the similar results with even more effectiveness and 50% to 60% less weight, with just $300,000 to $400,000. So there is a lot of mass savings, but also cost savings, and that's something that we're working with a prime aerospace company at the moment. And those are like some of the numbers that we've provided them with.
Excellent. Thank you.
That's pretty awesome. That's another inflection point in space development. So thanks, Mohammed.
You're welcome, man. Thank you for the question.
Yeah. All right. So we've been going now for 40 minutes. Any other questions from the audience? I know a couple of people have hopped into the call. So I wanted to put out a final question either in the chat or just raise a hand and jump in. Otherwise, thank you very much, Mohammed, for taking the time. It's always great to be able to connect with you and learn more. I was familiar with a lot of your work. We had a great conversation in prep, but this was really the first time I kind of dug down deep into some of them, and it really is a great story. Not only is it a highly applicable technology, not only to space but also to Earth in a number of different industries, but it's innovative, potentially revolutionary, and just the way that you built it. Like the idea came, and you just, nope, we're gonna make this work. Built a team, did it here in New York, found partnerships here in New York, and I think it also highlights some of the work that needs to be done. It highlights some of the reason why Empire Space exists, to raise these issues and highlight the companies and make sure that New York is doing everything it can for these companies that start up here with the great ideas, that they can scale and manufacture and produce and grow and continue to innovate, and can continue to do that here in New York. So thank you again for joining us and taking the time. I'll give you the last word for the day.
No. I believe it was great, and thank you so much for having me here. And yeah, Rama, Quadri, and then also Evan, you guys are doing great work. Stephanie, and then also Steve, thank you for joining. And I think it's all about following your curiosity, right? And then it can lead you to some places. And that's what I did, and then followed my own curiosity, like I mentioned earlier. So that's something that's keeping me going. And then we're really excited to keep building. And ultimately, enable deeper space missions, and then also protect astronauts. So that's like the ultimate goal, right? An astronaut coming to Melagen Labs team and then saying, "Oh, I was protected by your shielding, and then I was okay in space," and then also a lunar habitat, right, on the moon with our shielding. So that's like the ultimate driving force, and that's what just keeps us excited about building this out. And again, I really appreciate you for having me here.
Absolutely. Thank you so much again. Thank you everyone who joined us. It was a great conversation. So final shout out. Thank you, Mohammed, for all the work that you do. All the links are in the chat. Yeah, everyone have a great day. Be well.
Awesome. We'll catch you guys later. Bye.
All right, have a good one.